All right, so I'm going to talk about greenhouse gas emissions from electric vehicles now and into the future. But first of all, we've done a lot of work over the last few years, and all this information is publicly available. So if you're interested in the technical details, please go to the website and have a closer look. First of all, the emissions challenge. So what is the problem? Well, the problem obviously is climate change, and we need to reduce fossil fuel emissions as soon as possible. So when you look at global road transport, they use 3 trillion liters of fossil fuels each year. If you put it in perspective, that's about 12,000 pools filled with fossil fuels each year, which is one of those pools every 45 minutes. So it's a massive scale in terms of the issue. But the good news is that change in transport can be very fast and disruptive. So when you look at New York in 1903, there was only one car, and then 10 years later in the same streets, there was only one horse carriage left. So things can be going very fast, as we probably going to see with electric vehicles as well. In order to fairly compare emissions from vehicles, you need to look at the whole life cycle, which means you need to look at the vehicle cycle, which is the production, manufacturing of vehicles, as well as the disposal and the scrappage and recycling of vehicles. The other aspect is the energy cycle, which is often referred to as well-to-wheel, vehicle-wing, depending on the transport mode. And that includes the driving on the roads, the infrastructure to generate the fuel and electricity, and basically that's a short overview of that. In our studies, we have consistently found that rapid electrification of the Australian on-road fleet will reduce life cycle emissions of greenhouse gases in the future. And obviously it will continue to drop as the electricity system is increasingly decarbonized. So when you talk about pure battery electric vehicles, so we're not talking about hybrids, we're talking about pure battery electric vehicles here. In 2018, they already had a significant emission reduction per kilometer of 30 to 40%. But in the future, when we only have 10% fossil fuel left, that will be 75 to 80%. And that's not really the future. In Tasmania, we already have mostly renewables. So in Tasmania, we already achieved those very deep reductions in greenhouse gas emissions per kilometer. So battery electric vehicles are a really good option to reduce your climate change impacts. For trucks, it's more or less the same. In 2019 though, for the really big trucks, the diesel trucks performed better on a life cycle basis than battery electric trucks. But again, this is going to change very quickly when we have a decarbonized electricity system, which is happening all over the country. We get deep reductions of 75 to 80% in emissions per kilometer. So again, battery electric vehicles are a robust way of reducing emissions from road transport. Interestingly, the hydrogen trucks is talked about a lot, but they don't have the same impact. In fact, battery electric vehicles perform 50% better in terms of greenhouse gas emissions when compared with hydrogen trucks. Coming back to the life cycle emissions, so which aspects of life cycle emissions are most important? Vehicle cycle, so the manufacturing and the recycling of vehicles make up about 15% of total emissions for petrol and diesel cars. It's higher for electric cars, 25%, but as I said before, the total emissions are much lower compared to petrol and diesel cars, so overall they're much better. For trucks, it's about 1 to 5% for diesel trucks, and again higher for 5 to 25% for electric trucks. But the main message here is that most of the emissions, even if you look at the whole life cycle, occur during driving on the road. That's where most of your emissions occur, not in the actual vehicle manufacturing side, although it needs to be included, obviously. Vehicle size, vehicle weight, and technology really matter. So I hope you can read this chart, but basically it shows the number of kilometers you can drive before you emit 1 kilograms of CO2. So a large diesel SUV in 2018 in Australia would drive about 3 kilometers and would then emit 1 kilograms of CO2. When you look at a battery electric car, like an SUV, it will be double that. So you have 6 kilometers of driving before you emit that amount of greenhouse gas emissions. Of course, when you have an e-bike, a really small, light vehicle, you can do a lot more kilometers before you have that same amount of emissions. But this was 2018. So when you look at the future, where we have a very clean electricity grid, the situation is quite different. There's maybe some marginal improvement for diesel vehicles. Instead of 3 kilometers, you can drive 4 kilometers for 1 kilogram of CO2. But when you look at the battery electric SUV, you have 55 kilometers. The battery electric lighter car would be 125 kilometers, so about double that. And the e-bike gets you almost 2,000 kilometers before you emit 1 kilogram of CO2. These are approximate numbers to give you an idea. So this is my dad on the left side in 1968 in his cool little car, looking like one of the Blues Brothers. And then that's what basically the sort of vehicles they were driving at the time. And at the other extreme, we've got this very big Ram truck in 2024, which is about 5 times the weight of the vehicle that my dad was driving in the 1960s. So why is this important? Well, vehicle mass is very important for energy efficiency, fuel consumption and emissions, as well as safety for people and animals outside the vehicle. So basically, the higher the vehicle mass, the more energy, the more fuel, the higher the emissions. So it's important from that aspect. And also, I guess parking spaces and roads can be impacted as well. But those were two extremes. To be a bit more clearer, so what's happening in the Australian fleet is that cars have become bigger and bigger. And we basically went from standard cars to SUVs and utes. So why is that important? So we did a study with the International Council of Clean Transportation, and you can see that Australia has significantly higher emissions per kilometer as compared to even the US, who has large vehicles as well, but also China and the European Union. So this is the impact of driving heavy, large vehicles. We also spent quite a bit of time looking at potentially misleading statements. So you might have seen in the online media, for example, that statements about battery electric cars leading to a large increase in vehicle mass, and other things that were said about that. When you actually look at the Australian situation and you look at the top 10 sales data, on the left side you can see on the axis you can see the car weight of the vehicle, and then for petrol and diesel cars you can see first of all that the circles, most of the vehicles are actually still diesel and petrol cars. But in terms of the weight distribution, and you look at the pure electric battery cars, most actually are at the top end, whereas the electric cars are sort of in the middle, most of them. So as a consequence, the average mass of electrification will only lead to 3% higher average fleet mass. So in Australia, because we're already buying heavy vehicles, it is not going to have a lot of impact. Maybe it has in countries where there's a lot of small cars, but not in Australia. So that sort of statements don't really hold in Australia. Again, if you're interested in the details, there's information on the website you can look at. This is one of the studies we did a few years back. Again, this can be downloaded as well. So this is looking at what can we expect to happen in the road transport sector out to 2050. Well, first of all, it's important to realize that the total amount of travel, which is vehicle kilometers traveled, is expected to increase significantly. So when you look between 2019 and 2050, we expect about 55% increase in total travel. So we have more travel on the roads. We also, like what I talked about before, we expect a further shift to heavier passenger vehicles. But more importantly, there's a natural and very slow penetration of low emission vehicles into the fleet. So even if you have 100% electric vehicle sales now, it takes 10 to 20 years to actually percolate through the fleet. So we're still stuck with a lot of the fossil fuel vehicles. When you look at the charts, they sort of high-level charts. The green is the penetration of electric vehicles for passenger vehicles, light commercial vehicles, rigid trucks, articulated trucks, buses and motorcycles. The blue is hydrogen. So you can see it takes a while before it actually is significantly penetrated into the fleet. So that's really important. So what we buy now doesn't mean things are changing immediately. And just look at some high-level outcomes there. So the estimation is for 2050 that we need about 60 terawatt hours of electricity, which is less than 25% of the current generation. So often you hear, we need to double our grids. But when you look at the actual demand for electricity for electric vehicles, it seems quite doable. We need about a little bit short of 100 kiloton of hydrogen to power the hydrogen trucks, if that's going to eventuate. But I think more importantly, the main finding of the study is that even with this quite ambitious electrification, we're still only 35 to 45% lower in terms of total greenhouse gas emissions as we were in 2019. So there's a very big compliance gap. We're not going to reach the net zero gap, net zero targets in 2050. We're far short of that. The other interesting thing is that battery electric vehicles, as you can see, are expected to make up the bulk of travel, about 70%. So total kilometers traveled is about 70% for battery electric vehicles in 2050. But because they're highly efficient, they only make up a quarter of total energy used and only have 10% of the emissions because of the decarbonization of the grid. We still expect 30% fossil fueled vehicles like diesel and petrol cars in 2050 because of that slow fleet turnover, and they have about 75 to 90% of the total emissions. So although they have a small portion in the on-road fleet, they still have a large portion of the total emissions because of their inefficiency and high emission levels. So what does that mean? The conclusion is that electrification and hydrogen alone are not going to be enough to meet the net zero targets. So what we really need is lightweighting and focus on energy efficiency in road transport, which is critical to reach a significant reduction in emissions and meet the targets. So basically light electric vehicles are the way to go in terms of climate change impact. But we also need to look at avoiding travel, shifting travel and improving. So improving was about electrification. The next one is about shifting. So we can also shift to different transport modes. So we published this study 2 months ago where we looked at the route between Brisbane and Melbourne, and we looked at a whole range of transport modes that are specific to Australia. So for example, we looked at the types of ships, the bulk carriers and the container ships that are being used in Australia typically. We look at the aircraft that are typically used in Australia, the Airbus 320 and the Boeing 737. We looked at the typical trucks, the B-doubles. We also looked at high-speed trains, which are not really available in Australia yet, but it's an interesting option. And of course, we did a very detailed simulation of the on-road fleets as well. We looked at 3 years, 2019, 2030 and 2050, and we also looked at personal travel and freight. So going straight to the conclusion, actually this is about the methods. I don't want to go into all the details, it's very detailed modeling. The message here is basically we did some very detailed simulation that is mode specific. So for each mode we have different models, different algorithms to account for the specifics of the transport mode. But in terms of the conclusions, when you look at the grams of greenhouse gas emissions per passenger kilometers or the grams of CO2 per ton kilometers, which is for freight, electric rail provides very deep and robust greenhouse gas emission reductions, which is not surprising because an electric rail is basically an electric car, so they're highly efficient in their energy use. Shipping for freight is also low, but it's more variable and uncertain. But aircraft emissions are very high, in the order of 7 to 10 to 20 times higher for passenger travel, and it was much higher for freight because of the loading capacity of planes. In fact, it could even fit on the chart, so that's why there's a little disclaimer on the right. The last point is there's different decarbonization trajectories, which means that electric rail decarbonizes very quickly, So cumulatively, those emissions reduce very quickly, whereas for the other transport modes, that's not the case. And this is really important because it determines the total amount of emissions by transport mode. And that's me. Thank you. Yes, please. Sorry, I couldn't hear.
What was the question, sir? What do we think about hydrogen in the future?
Yes, sure. So hydrogen, I think it certainly has a place in the economy, but for transport, it's less efficient in terms of energy use and emissions, and more costly. So I think for transport, it's probably going to be the less preferred option in general.
But why, Robin? Tell people why. You know why?
Yes,
we can speak. The young man wants to know. Tell him why.
Yeah. So basically, the main reason is that when you look at hydrogen trucks, the energy efficiency is much lower, basically. So it takes more energy per kilometer to produce the hydrogen and then to distribute it. And there's lots of uncertainty as well in terms of the durability of the fuel cell systems, which would mean that you, for example, would need to replace the fuel cell more often and therefore increasing the total emissions as well. So there's a whole range of issues with hydrogen at the moment that haven't been resolved, which basically is reflected in that uncertainty as well in the emission factors. So I think in general, battery electric is more robust and obviously very quickly changing for the better. And then the other side is the costs as well, which seems to be more expensive in general than battery electric vehicles. So that's, in short, the answer.
I can give you the long version, thank you. He's obviously a professional, I'm more of a loudmouth. And Steve Bloom from the Smart Energy Council sitting behind us. I can't hear me. So the other thing about hydrogen is you can't make it green. Even in Tasmania, if 25% of the power goes to Bell Bay and 12% goes to this company and 10% goes there, not only don't we have enough water where we want to produce it, but nobody wants to drag the water out of Bass Strait to make it. We want the government to pay for it. Well, the government's only going to pay for it for so long. You and I aren't going to tolerate subsidising another fuel source when I can get Robin to my house, put in some panels, buy a car and start saving money. It's like, so we're trying to fit the old fossil fuel mentality back to a new fuel. And without government subsidies, it wouldn't last a minute and a half and it'd be a joke. Will we find something else that's not hydrogen? Maybe. Will someone crack the code of hydrogen so it doesn't leak when you transport it? Maybe. But in the meantime, 3 units of energy in, 1 unit out, that one can't be done with subsidies or demand, or is it better than a battery? It just can't happen. We heard some stunning stuff yesterday, didn't we, Robin?
Yeah. And I might just say as well that it's good to be critical about hydrogen. 20 years ago, it was sort of, they said it's the fuel of the future, and we're sort of still saying that at the moment. So there's lots of technological issues. You need green hydrogen, obviously, which can be produced, but that's where the efficiency issue comes in. So I think we have to be critical. But for certain sectors like the production of iron or steel, it could be very, very useful. Maybe for shipping an aircraft, but still to be seen, because there's an energy penalty to be paid for hydrogen.
But not with hydrogen. Yes, it's already happening. Well, you should have come to the conference yesterday. We could have sold you a new plane.
Yeah, I think the main issue, so ideally everything is battery electric, but when you start looking at shipping and aircraft, they have very long distances, which the battery cannot provide. So you need to look for alternative options for long distance travel, long haul basically. So things like biofuels are being looked at, but there's lots of issues with that as well. I think the European aircraft manufacturers are seriously looking at hydrogen as well as a fuel, but that's a very sort of specific application for long-range aircraft, basically. Same for shipping, where there's different options on the table. So ideally, you like battery electric for short sea shipping or for short trips. But for the really long distances, we still need to look at alternatives.